All right. In a previous video, we learned how to measure the angular diameters of planets from images that we collected with Skynet. In this video, we're going to learn how to check those results using a program called Stellarium. Now, Stellarium is free software, and you should already have a copy installed on your machine. I'm going to share my screen so we can look at mine. Now, when you first open Stellarium, it can be a little annoying. It fills your entire screen, and there's no obvious minimize button. So just remember, function F11 forces it to minimize, and then you can size it however you see fit. Now, the next thing we need to do is change the time zone in Stellarium to universal time. This is because you've collected a handful of images, you've opened those images in Afterglow, and you recorded when Skynet took those images. And you recorded those times in universal time. So we need to get Stellarium also working in universal time. So to do that, come over here to the left, and you see this bar will pop up. It has a variety of different tabs, a variety of options. You want the one at the top called Location Window. Click on that. And from here, you can change your location on Earth in the simulation by clicking on the map or by typing in different cities. But we're not going to do that in this lab. I'm going to show you a workaround. But first, we need to set the time zone. And looking at it, the time zone is currently set to my system default. That means it's just using my computer's time zone, which happens to be Eastern time. And that's not what we want. We want universal time. So to change that, first you make sure that custom time zone is enabled, and it is. That lets you go into this menu here and pick a different time zone. If I scroll up a little bit, you see all these UTCs, UTC -7, UTC -6. If you go to the top of this list, you'll see UTC by itself. Click on that, and you're in universal time. Just one last thing, disable daylight savings time. We don't need that. Okay, so once you've done that, you're now in universal time. But word to the wise, don't change your location. If you click on a different location on the map or type in a different city, it could change the time zone to that city's time zone. And we want it to stay in universal time, so we're not going to change our location for this measurement. But we've collected a whole bunch of images. Those images were taken by different telescopes at different locations. So what are we going to do? Well, let's close the location window and come on down here to the bottom. You see there's another bar that will pop up with a variety of tabs. And what you want is, first, this one here looks like a pair of trees, and that's the ground. If you click on that, you can turn off the ground. So we got rid of Earth. And if we go over 2 tabs, there's one that has a cloud and the sun. If you click on that, you get rid of the atmosphere. So now it doesn't matter where on Earth you are, whether it's daytime or nighttime. We've gotten rid of the Earth, we've gotten rid of the atmosphere, so we're just looking out into the sky. Okay, now, I imaged Jupiter and Saturn, so let's start with Jupiter. I'm going to go over here to the left. Here's the pop-out, and I'm going to go to Search Window, and I'm going to type in Jupiter. It will take me to the current location of Jupiter. Feel free to zoom into it. I'm using the scroll wheel on my mouse. You can also page up and page down to zoom in and zoom out. And you notice it's kind of tipped. In your image, the moons were probably horizontal. And you can get Stellarium to match the orientation of your image, at least approximately, if you want. Just come on down here to this bottom pop-out tab. You see the one that looks like a telescope? If you click that, it will reorient the sky to match what a telescope would acquire in an image. Okay, so here's Jupiter, and this is Jupiter now. We want to know what was the angular diameter of Jupiter when Skynet took that image for me. So the last thing we need to do is change the time. So again, come over to the left, and it's now the second one down, the one that looks like a clock, and it's date and time. And I'm looking, and the image that I took it in 2019, February 24th at 9 hours, 9 minutes, and the seconds really don't matter. Okay, so I've changed the date and time, and if I want to know the angular diameter of Jupiter, I just come over here to the left. Here where it says apparent diameter, that's what we're looking for. It says 0 degrees, 0 arc minutes, and 35.73 arc seconds. Of course, this is for the image I took. For the images you take, you will have different angular diameters depending upon when you took your images. Okay, so that's the answer for Jupiter. Let's just do one more. That's Saturn. So again, I'm coming to the left. I'm going to the search window. Type in Saturn. We'll repoint the sky. So Saturn is there, filling my field of view. You can zoom out, zoom in. See all the moons around it. And lastly, I need to change the date and time to match when I took my picture of Saturn. So my picture of Saturn, I took it in 2018, October 1st at 3:31. Again, the seconds don't matter. And if I come over here to apparent diameter, you'll now see two numbers. The first number is the angular diameter of the planet, and the second number is including the rings. And so from one side of the rings to the other, it's 38.34 arc seconds, or at least it was when I took my picture. It will be different for you. Now, with Saturn, you're measuring the angular diameter of the rings. With any other planet, you're measuring just the angular diameter of the planet. So make sure you use the right one. With Saturn, Uranus, and Neptune, it will give you both. But only with Saturn do you want to use the ring value. Everything else, you use the planet value. Okay, that's it for this video.